In today's lesson, we're going to look at multiplying mixed fractions. In an earlier lesson, we talked about adding mixed fractions. For example, 3 1/3 plus 5 1/3, for example. 3 1/3 means 3 plus 1/3. And 5 1/3 means 5 plus 1/3. So since it's all addition, the brackets don't really matter. We don't have to do the brackets first and then add. So we can switch the order up and just say it's 3 plus 5 plus 1/3 plus 1/3. And in other words, we can just add the whole numbers, add the fraction part, and we have our final answer. We can leave it in mixed form to add. But with multiplying, 3 plus 3 over 5 multiplied by 2 plus 2 over 9, we have to do the brackets before we multiply because it's not all the same operation. So in order to do the brackets before you multiply, we change our fraction to an improper, because changing our fraction to an improper is adding the 3 into the 3/5, right? 3 groups of 5 is 15, so 15 over 5 is 3. So 15 added to the 3 gives me 15 over 5. Now I'm going to say 2 groups of 9 is 18. Add that to the 2. And so by changing our mixed fractions into improper, we have added those fractions together, and now we can multiply. So when you're multiplying mixed fractions, you have to change them to improper. Changing them to improper is the same as adding those together. And at this point, we can look for our canceling. We can reduce if a numerator and a denominator have a common factor. And then, oh, look, 3 goes in there. All right, we've reduced that down. And now that we've done all of our reducing, we can multiply our numerators, multiply our denominators, and change them into mixed if we're left with an improper fraction. All right, let's try another one. 4 4/5 multiplied by multiplied by 4 3/8. So we must change to improper. 4 groups of 5 is 20. 20 added to the 4 is 24/5. Multiplied by 4 groups of 8 is 32. 32 plus 3 is 35/8. Now that we've completely we've changed our mixed to improper, in other words, we've added the whole number into the fraction and we've combined, we can now multiply. We can look for our reducing before we multiply. And now we can multiply. The numerator times the numerator is 21. The denominator multiplied by the denominator is 1. When you have 1 in a denominator, you do not need to write it anymore. So this fraction becomes 21. Okay? So remember what multiplication means. It's repetitive, right? I want to know if I'm traveling 4 5/5 of a kilometer or kilometers, and I travel for 4 3/8 hours, how far have I gone after 4 right? If I travel that far per hour, how far have I gone for 4 3/8 of an hour? So you're accumulating. You're adding this 4 3/8 times. It's kind of confusing because it's not a whole number. We're used to saying added exactly 4 times. But with a fraction, you're adding it 4 times plus 3/8 of a time, which is a little confusing. We can also do that with 3 fractions, right? So if we have 3 fractions, we can multiply all together. So I'm going to change them all into improper, right? 15 plus 3 is 18. 4 plus 1 is 5. So once they're all improper, I can look for my canceling. 1 and 9. Oh, the 5s, that's handy. Anything else? I see nothing else. So now I'm going to multiply, and I'm going to get 45 over 4. 4 goes into 45 11 times with 1 left over. All right, so that's multiplying fractions. Let's try a couple word problems. So here's an example like I said earlier. We know that a car travels 11 2/3 of a kilometer on 1 liter of gas, right? So that's how far it goes on 1 liter of gas. How far can the car travel with 4 1/5 liter of gas, right? So sometimes when you have trouble on a word problem, sometimes I just ignore the fraction. So if you don't know what to do, sometimes I ignore those fractions and think, what would I do if the fractions weren't there? A car travels 11 kilometers on 1 liter of gas. How far can it travel on 4 liters of gas? Well, it goes 11 kilometers for every liter, so 4 times 11 would be 44, right? It can travel for 44 kilometers with 4 liters of gas. So once I throw the fractions in, it's the same idea. I now know I need to multiply. So I'm going to take 11 2/3 and I'm going to multiply by 4 1/5. And again, I have to change them to improper. 11 groups of 3 is 33 plus 2 is 35. 4 groups of 5 is 20. 20 plus 1 is 21. So that's a 5. And then I'm going to do some canceling. Looks like there's lots of canceling, which is nice. And so I can see that this car can travel for 49 kilometers. In a word problem, you want to give a nice unit to answer the question, on 4 1/5 liters of gas. Degrees Celsius can be converted to Fahrenheit by multiplying. So if I have degrees Celsius, I can multiply it by 1 4/5 and then add 32. 1 4/5 is very close to the number 2, isn't it? That's why the rule is if you have degrees Celsius, we simply double it and then add 32. That's a nice estimate for how to convert from degrees Celsius into degrees Fahrenheit. Canada, we use degrees Celsius. United States uses degrees Fahrenheit. So for example, if we had 15 degrees Celsius here, my average, the way I would estimate it in my head is I would double it. I would get 30. Then I would add 32. And I would get 62 degrees Fahrenheit. So therefore, 15 degrees Celsius is approximately 62 degrees Fahrenheit. But the actual way of doing it is to use 1 4/5. That's more accurate instead of just an estimate. So if I have 15 degrees Fahrenheit, if I have 15 degrees Celsius, what is it in Fahrenheit actually? Well, I'm going to take 15, I'm going to multiply it by 1 4/5 first, and then I'm going to add 32. So I'm going to take 15, I'm going to multiply, change this to improper, 9 over 5. And so when I multiply those, I get, cancel, I get 27 plus 32. And the actual answer is 59 degrees Celsius. So you can see that my estimate was a little bit off. This is the actual conversion, okay? So that is multiplying mixed fractions.